So hello everyone. This is chapter 21. We will discuss in this chapter the testing and how we test our Shiny application in multiple layer. Um, so we have we will perform testing, use automated testing using test lab packages, package that requires turning your app into a package, but as discussed in chapter 20, this is not too much work. So this is how this that look like. We have like a description of the test, and then we define the text, the test itself, and then here we have like a vector, x vector, and then we expect this vector to be 1 or 2. And this is a expect equal, which is a function that defined in test that framework or package. Now, we'll come back to these details very soon, but note that this test starts by declaring the intent of as vector, which is the name that we already mentioned, then uses regular R code to generate some tests. The test data is then compared to the expected result using the expectation, a function that starts with an expect. There we have like a couple of functions that start with expect, which is expecting result, different result. We have an expect equal, an expect error, and expect other types of expects based on the results that we are seeing. So first argument is is some code to run, and the second argument describes the expected result. Yeah, so as we see. Now, we will see a 4 level of testing in this chapter. The first level is how we test normal function, which is called here non-reactive function. And normal functions is like where you test a normal R code without Shiny being involved in the process. And this could be like seen in very good detail in the testing chapter of an R packages book. So we will just like dip the toes and have this very brief summary of how you could test reactive functions. But if you want more details, you could go to the testing chapter in the R packages. So, and this is the first layer or the first level. Second level is how we test reactivity, the reactive functions in our Shiny apps. Third layer is how we test the JavaScript, which is update functions that's run in the background. So basically, we are running simulating a real browser to be open, and but yeah, the downside is that the test is slower than usual. So this is the third layer. The fourth layer, or the fourth level, we have the visuals. So basically, we are taking the interfaces or the layouts, CSS and plots and HTML widgets, and we try to see if this screenshots is actually like similar to what we expect it to be as a visual, which is very impressive because this is very hard to do in normal programming languages. So that is doing this for us, and we'll see how in a minute. So this level of testing for a natural hierarchy, because each technique provides a fuller simulation of user experience of an app. And the downside of better simulation is that each level is slower because it has to do more and more fragile work. So we tend to do like some kind of abstraction in this kind of tests. And that's why over time, this will also influence the way we write code. Knowing the sort of code is easier than test. Okay. So yeah, we just call the library, which is called the test that, and with this with shiny tests, and let's see how we would use in the four levels. Each one of them have its own way uh, or its own workflow, basically. So first one is testing functions. Normal function of our functions that we are using in day or daily basis, but we actually expecting a certain result, and we want to test that against that and see if it's really matching our expectation or not. So basic structure is we have a file and a test and expectation. The file is all test file live in test uh, dash the test that, and each test file should correspond to a code file. Um, so we could have like a module R should be tested by the code itself, and if we have module R, then we have test that test module R, and so on. Fortunately, you don't have to remember that convention. Just use test to automatically create or locate the test file corresponding to the currently open file. Um, so yeah, we actually like have this functionality to just automate the naming instead of remembering the naming convention itself. Um, so yeah, this is the file. How we could use this to just naming our files and uh, like taking the name of the file and create its corresponding test file into our test.dat folder. Now the test itself, each file is broken into tests. We call test.dat a test. A test should generally check a single property of a function. And this is what's called the unit test, which is we are testing a unit of a full application. And this is just like small functionalities that contribute to the bigger picture. It's hard to describe exactly what does this mean, but a good heuristic is, yeah, it's mean that we just like we testing just the basic functionality, the core functionality, it's abstracted logic without going into the details of the logic. So we'll see that in a minute. So yeah, and but a good heuristic is that you can easily describe the test in the first argument to the test.dat. Yeah, like we have seen here, we just describing the test, and then the test we define a value, and then expecting the value to be equal to a vector in one or two. Same as this is a very basic structure. That's why we see here it's similar. Now, the expectation, each test contain one or more expectation, which functions that start with expect underscore. These define exactly what you expect code to do, whether it's returning a specific value, throwing an error, or something else. Yes. In this chapter, we will discuss the most important expectations for Shiny apps. And we have the full list in this website. So here we have expect equal, expect identical, expect null, expect type, expect S3 class, S7 class, S4 class. So yeah, it's basically we just here we expecting or testing the type of an object. Is it like null? Is it S3 class, S7 class, S4 class, or what its type exactly? And we have a vectors. So this is an object, testing objects. We have testing vectors, which test. We could test the length of the vector, the less than or equal, greater than or equal, and so on and so forth. Yeah, so you have like a very good amount of listing of how we could test using expect to test a specific thing in our Shiny app or in our R code. Here we have a snapshot, snapshot values. Yeah, it's basically a lot of testing functionality that we could use, leverage in our code. Yeah, and this is very good to play with in your free time. Let's go back and see what is, yeah. Okay, so these define exactly what did you expect the code to do. Yeah, whether it's returning a specific value, throwing an error, or something else. It's in the chapter. Okay, we already taught. Yeah, the art of testing is figuring out how to write tests that clearly define the expected behavior of your functions without depending on a incidental detail that might change in the future. So yeah, as we said, that we are testing the abstraction logic, the abstracted logic, not um, the yeah, not not the actual functionality itself. That's there's some logic that's changed by time and have a dependency on other uh, uh, program or a function that will not test. That's why when we design our structure or we design our code, it's a good practice to have this unit tests as um, as a basic way to build our structure or app structure. Every function have its own test that it should be doing just one thing and just one thing. Um, so yeah, this is the first thing is the basic structure. Now the basic workflow. Now you understand the basic structure. Let's dive into some examples. We see here that this function is loading a file using the tool library, like a file extension with a name. And we have a switch statement, if either a CSV file or TSV file, based on its delimiter. Of course, can do that and see if it's one of is not one of those, then validate its invalid file to upload. So for the sake of this example, I'm going to pretend this code lives in R. Yeah. So here he's trying to see how we could use the test that to test this function. Basically, what it did is actually like describing, as we said, describes the test itself with a function, handles all input types. So it should handles all kind of inputs. Of course, it's not like that because just it's handling just two inputs. So yeah, it's maybe he just missed that one, but he like he focusing on the validating these just two types of the functionality of uploading a file. So that's why here it's just build a test on that. But the description is off, I think. So this is create a simple data, and we have a tuple, and a temp file, which is a temporary file that we created to simulate the file that we want to upload or load, sorry. And we write this file into the DF using this write.csv and write to table. And now after we did that, actually we did this in two ways. The table use it to do it with TSV, and the CSV to do it with CSV itself. And so yeah, we use the expect equal here. We expecting this the output of this load file function to be same as this df, Um, and since this load file is returning in the end, uh, um, the output of it is as data frame. Now it's comparing between the data frame that we are um, assigning it here in expect equal and the data frame that coming back or returning from load file. So if it's equal, it will return it. If it's not equal, it will not pass this test, and it will call like invalid file. So yeah, this is how he did this. He he have four ways. First way is running interactively in the console itself, and or like the second way is test the whole thing at once. If it fails, it's you get the detail of what's wrong. Third way is when he developed, run the test in the current file with dev-tool test file. So this could be in the shortcut. You could like have it with a shortcut in the RStudio to do this for you. Yeah, and he actually recommended it here. Yeah, so every now and then I run all the tests for the whole package with test. Yeah, so this commands using the dev tool and test file. It run all the tests in your current file immediately. And to run the test in the whole package, use test instead of test file. And this will run all the tests that exist in the package itself. Sorry. So yeah, this is how he did test, and of course, this is actually very basic R testing that we are experiencing here. But since R is the main language in Shiny, and we actually did abstraction and have our own functionality that abstracted away as a functions, and we use this function to like transform our data frame or do some manipulation in the data itself, changing the data types or having this kind of pre-processing step. So this will actually test this pre-processing or functionality of transformation. So that's why it's very important to know. Now, the expectation, we have two expectation. You will use a lot, which is expect equal and expect error. Like all expectation functions, the first argument is a code, yeah, and to check, and the second argument is expected outcome. So yeah, as we said here, this is a code that we will test, and this is the expected outcome, which is this df. Yeah. Okay. So when using expect equal, remember that you don't have to test that whole object generally. It's better to test just a component that you are interested in. So yeah, it's you don't need to have like a very specific test for every object. You could like test just a very small portion of your object. Here we have this object that is a list object, and we actually could test one of its component, which is y. So which test is y is equal to 10 or not. And yeah, so it doesn't have to be the full object. It could have like a portion or one element of the object, and yeah, it works fine. So there is a few expectation for special cases of expect equal that you can save little typing. So we have expect true, expect false, expect equals, which is having this the same x or to be false and to be true. Oh yeah, so this is a shortcut. Just shortcut instead of expect equal to false, expect equal to true. We have an expect true and expect false to test the truth or value of of an expression or a function. So we have also expect nulls is equivalent to expect equal x and null. Yeah, same. And we have expect named is equivalent names, and we have expect length, as we said, we see in this page here. Yeah, we have all this kind of expect functionality. So here we have the expect error as well. But yeah, it's not like, yeah, it's pretty easy like to understand. It's very intuitive. Like if this happened to have an error, if this function have an error, just return a message called calculation failed and with a location. So yeah. Okay, so here we could use this expect snapshot that we have seen in the page before. We'll discuss shortly. Expect error also comes with variant, expect where warning and expect messages. We're testing for warning and messages. Okay, so yeah, it's not, it didn't go into the details, but yeah. Yeah, it's as it said, if you want to go into the more detail, more in depth, you could go with the testing chapter in the R packages. But yeah, let's go to the user interface functions, and this functions is how we could test. Yeah, so the idea of test function to that you have extracted out of your UI code, but this require a new expectation. So okay. Yeah, I don't see this is like a good test case. You see here, if this is a complex design interface, so if you try to have this as your expectation, you have to write the HTML, all the HTML yourself, which is not very convenient in my opinion. So I wouldn't like recommend to just test UI functions like that. But yeah, the presence of quotes and the new line requires a lot of escaping in the string. Yeah, so you have to deal with this escaping characters in between the strings, because this is a string is will identify as it. This is a string and this is a string, so how it should escape this double quotation or not. We use this escape character, so you have to use it everywhere, which is again very complex for just wanting to testing a simple HTML. There's another ways, and we have the testing visual for that, as I think. So the key idea of snapshot test is to store the expected result in a separate file that keeps bulky data out of your test code, and means that you don't need to worry about escaping special values in string. Here we use expect snapshot to capture the output displayed on the console. So yeah, instead of doing this fancy stuff, very complex stuff, we just use the expect snapshot to save this the bulk data into a file, and then we test that file based on this input that we're giving it to use a snapshot. So yeah, this is the main difference with other expectations. There is no second argument that describes that what expect to see. And instead, the data is saved in a separate MD file. If your code is in R slider.r and your test in test slider.r, then snapshot will be saved in test underscore snaps slash slider.md. the first time you run the test expect snapshot will automatically create a reference output, which will look like this. So yeah, this is the same thing as we are doing here, which is expecting just a lot of characters with a lot of escapes. Yeah, so instead of doing that, we could leverage the expect snapshot to save this file in MD and um, see the result and testing the result using this expect snapshot functions. So very convenient for our usage and save a lot of time. If the output later changes, the test will fail. You either need to fix the bug that causes the fail, or if you the deliberate change, update update the snapshot by running test snapshot accept. It was completing the output here before committing. Okay, so it's just saying this association. So okay, what else? What is the workflow? Oh, okay, so yeah, it's different than um, the slides. So we talk here about the code coverage. So before we talk about the testing functions that use the activity or JavaScript, we'll talk about a brief digression to work on your workflow. So code coverage is what you're actually doing in the testing environment, and very testing if you have a software engineering mindset and or in your team in a software engineering team, you will actually will have a testing coverage, code coverage that uh, cover or test cases that could be happen, that could be damaged or do wrong with your application. So it's you have to expect that the wrong before it's happened with the test. And they call it like test driven development. But yeah, you could just you if you think about tests very well and you actually expecting the result every one time, every time you are creating a new stuff, think you are good to go. Um, so yeah, it runs their test, tracks every line of code that is run. You can then look at the result to see which lines your code are never touched by a test. Yeah, so you see which which is not tested and which tested, and by using this kind of functionality. Um, hard to program parts of your code. It's not a substitute for thinking about your code. You can have 100% test coverage and still have bugs. But it's fun, as usual, to help you think about what's important, particularly when you have a complex nested code. So the more that you have a complex logics about your business, the more you have a complex code, the more you'll find bugs, and bugs and errors is normally happening because of a human. Uh, us as humans, we will almost every time we will have this kind of buggy uh, development mindset because this is normal for us. But again, um, since no one is perfect, we could leverage this coverage test to just minimize the bugs that it's happening. Um, again, as I said, even if we have a test coverage of 100%, we still have bugs, but we will minimize it using these tools. So code coverage supports slightly different workflow. Use the test coverage or test coverage file to see which line. Again, here not really having even an example. He doesn't have he doesn't go into the details. He just say if what is the best practices that you should do in terms of code coverage. So look at untested lines and design the test specifically to test them. Repeat until all important lines of code are tested. Getting to 100% test coverage often isn't worth it, but you should check that you are hitting the most critical part of your app. Okay, so yeah, this is that bug. We could now go to the second level, which is testing reactivity. And I think this is the the most important one, since we are using reactivity in the daily basis and in Shiny. So now that you understand the test, regular tests, and the first challenge is testing reactivity. As you have already seen, you can't run reactive code interactively. You can't run reactive in your console. So how you could test that, since we can't run individual tests on each pieces like we did in the regular functions. So unfortunately, its simulation of reactivity depends on fundamentally on an interactive console, so won't work in tests. Not only does the reactive error when we attempt to evaluate it, even if it did work, like in input Y and input Z, wouldn't be defined. To see how it's worked, let's start with a simple app. Okay, you have a fluid page, have a three numeric input, 0 and 1 and 2, which x corresponds to x and y and z. We have a text output, which is like how we could like outputting uh, our data. What we do? We have an x minus y and z plus y, and then we have this xy function, which is the reactive function, and we have yz uh, as another reactive function. We do this, and we have another reactive function that depend on the first two. Okay, so and then we paste that into the rendering text, which is this one, and yeah. So to test this code, we will use test server. This function takes two arguments. First one is the code that you will run. Okay, the code we will run is the server function. So first, we will give it the server function. It's the name of the server function that we will test. Second is, so you can access outputs. This code is special environment server object simulate interactions. The main time you will use. Okay, two arguments, server function and some code to run. The code is run in a special environment inside the server function, so you can access outputs and reactives and special sessions objects that allow you to simulate user interaction. The main time you will use this is for session set inputs, which allow you to set the value of an input controls as if you were a user interacting with the app in the browser. So yeah, actually we could simulate um, a browser opening and a user interacting with the browser using this set inputs. Um, like we are creating a new session and giving the values to the input itself, and all of that using this set inputs function. So yeah, after we did that, simulating the output, the input, typing in each one of them the values. This is one, and this is one, and this is one. Okay, we have three ones, and we we call this xy, which is x minus one. It should be zero. One minus one is zero, and yeah, it's zero here. And yeah, the output, anything with multiplied by zero is zero, so we have a result of zero. So you can abuse the server to get an interactive environment that does support the activity. So the server is taking my app and a browser functions, or something that will simulate a browser, So note that we are only testing the server function. The UI component of the app is completely ignored. You can see this most clearly by inspecting the inputs. Unlike the real Shiny app, all inputs start as null, but because the initial value is recorded in the UI. We'll come back this to in the section 4, which is how we could test using JavaScript. So yeah, we said that. Okay. So yeah, without simulating anything, using the set inputs, if we just print the input, the X input, like um, uh, input as an input, like here, so it should like return null. So since it's the default value is null. Yeah. Now that you have a way to run code in your active environment, you can combine it with what you already know about testing code to create something like this. So since we have test server that we could simulate a reactive interactive environment for tests, we could use that with test that function. So we are here reactive, like testing the reactive and outputs updates. So this is how we could describe it. Then we could use a test server, give it a servers function, and then call the set inputs again. And by doing that, we expecting the result. Now, since we see that the output here is with prints, now we could expect the result using the expect equal or expect error or any kind of expect in this long last. So yeah, once you have mastered the use of test server, then testing reactive code becomes almost easy. Testing non-reactive not as easy as testing non-reactive code. Yeah. So you'll need to add a browser inside of it. So you can step through them line by line, like a regular test. So you will need to add a browser. Yeah. Um, okay. So what is modules? So you can test a module in a similar way to testing an app function. So the meaning of module here is a full, like the module that we talked about in chapter, I know it's chapter, I think 12, 19, yeah. So in chapter 19, we talk about modules. Now, how we could test modules based on their reactive functionality. So you can test module in a similar way to testing an app function, but there is a little more clear that you are only testing the server side of the module. Let's start with simple module that uses three inputs, three outputs to display a brief summary of a variable. So you have three text outputs, main, minimum, and main and maximum. And this we have a summary server, which have this functionality of getting the ID and then stop if not is active. It should be active to be null to be true. And we have a module server that taking ID and taking the server function that having input, output, and session. And in the server function, we have a range value and we define the three outputs that we are declared in our UI. Okay, so here, how we could test something like that. So we will use, again, test server, but the call is a little different as before. The first argument is the server function. So here we will have the server function and now the module server, like the server function is the module server itself, since yeah, it's containing the output and the input, but the module server, it contain the server function. So that's why uh, the one that's called is a server is a module server, which calls uh, inherently the server function inside the module. So, but yeah, now we also need to supply additional argument in the list called args. So this args, which is this args is a list of arguments to the module server, and we have the ID argument is optional. The server will fit it in automatically if omitted. Yeah, and then we finish up with the code to run. So basically, we give it an arguments, a list of arguments to pass it to the server functions. And here, again, we can turn this into automated test by putting it inside test set. Yeah, same as we did here in testing the reactivity. We could actually do that same thing with the module, but with a different kind of structure, since we are like giving it the reactive values or the reactive um, functions itself as a value in its argument to be able to use it inside the test server function. Now, since this is already defined, we could use it here to define the range, since X here is a range, I think. Yeah, this one. And you see it here. Yeah, so as is this one. Okay. Mm, okay, there is one important trick here because X is created outside step search. Change X does not automatically update the reactive graph, so we have to do so manually by calling session flush react. So yeah, this is not a reactive context, since we are not calling a reactive and we are not inside a reactive. So this will not change the reactive graph automatically. So we have to have this kind of functionality manually, use it manually using this session flush react to enforce the changes into reactive graph, which is very like not that good in terms of practices. But again, since this is not a reactive context, we don't have a choice. So if your module has a return value and this return value is a reactive or list of reactives, you can capture it with session get returned. So if you see here, okay, okay. So if your module has a return value, okay, you can capture it with session get returned. Then you can check the value of a reactive, just like any other reactive. Okay, where is, yeah, this one, okay. Yeah, again, since this is not a reactive context, so the value is not saved in a reactive context or a reactive value or object. So here comes the usage of session return get return to capture the value of a reactive. Um, so yeah, if your module has a return value, okay, active or less active, you can capture it with session get return. Yeah. Cool. So yeah, we get just the return value of of this session, which is this module, and that we get from this is the package datasets, which is the name of the dataset. So we just getting it from here to here. And yeah, do we need to test what happens if the dataset isn't a dataset? In this case, we don't, because we know that the module UI restricts the option. Yeah, we have a valid choices to choose from. So the UI itself is restricted the output to be in the the choices that we are providing. So there is a limitation for this. So test server is a simulation of your app. The simulation is useful because it lets you quickly test reactive code, but it's not complete. Unlike the real world, time does not advance automatically. So if you want to test code that relies on a reactive timer or invalidate later, you will need manually advance time by calling session elapse. So it's not recoding time. Again, there's no reactive context. That's why we couldn't track the time. That's why we couldn't rebuild the reactive graph. So we have to do this now, like manually if you want to test that. And as well, test server is ignore UI. That means it doesn't like helpful in like testing the UI capabilities. So that's why we go to the third level, which is testing the JavaScript. Is test server is only limited simulation of the 4D Shiny app, so that any code that relies on a real browser running will not work. Most importantly, this means that no JavaScript will be run. This might not seem important, but because of we haven't talked about JavaScript in this book, but there are a number of important Shiny functions that use JavaScript behind the scene. All updates functions that we talked about in the dynamic UI, I think. We talked about in user feedback, show notification, remove notification, and we talked also about the show model, hide model in the user feedback. So these all the functions that are using behind the scene JavaScript. So to test this function, you need to run the Shiny app in a real browser. You could of course do this yourself using run app and clicking around, but we want to automate the process that you run your tests frequently. We will do this with an off-label use of Shiny test package, and you can use Shiny test as a website as the website recommends, automatically generating test code using an app. But since you are already familiar with test.dat, we will take a different approach constructing test by hand. So if we go into the test, Shiny test, and it said here the Shiny test is deprecated, you could see in the test, use Shiny test 2. Manually testing Shiny application is often laborious. Okay, so it's automating the process, and instead of us doing all the work for and use the test.dat, it's actually using test.dat behind the scene, but it automates the process of creating tests for reactive component. So this is why it's been helpful and it's used regularly to test Shiny apps. You can use test.dat as a website recommended automatically, yeah, generating test code using an app. But since you are already familiar with test.dat, okay, we will work on R6 object from the Shiny test package called Shiny driver, creating a new Shiny driver instance, start a new R process that run your Shiny app headless browser in a headless browser. A headless browser works just like a usual browser, but it doesn't have a window that you can interact with. The sole mean of interaction is via code. The primary downside of this technique is that the slower than the other approaches. It takes at least a second for even the simplest app. And you can only test the outside of the app. it's harder to see values of reactive values variables if you use this. Okay, so we have here an this is a basic operation, and we want to use testing that using test that. So we call the Shiny driver, and we creating a new instance of the Shiny app and give it the UI and server functions. And yeah, we're giving it a values like interacting with the app as it in the browser, but with code. So yeah, and we see the outputs. Yeah, the outputs like executing the server functions, which is greeting here. We give it the name of Hadley and then getting the value of greeting. They said hi Hadley, and so on and so forth. And every use of Shiny test begins by creating a Shiny driver object. And yeah, it takes set of names, value pairs. So yeah, you could see the Shiny driver class um, in the documentation as well. So yeah, basically you are interacting with, yeah, I see this as a similar way of testing in Python as well. It's simulating an headless browser, which is on a browser in the background, but we are interacting with this browser in using code. And you could do an event handling with the code itself. So yeah, and yeah, this is a case study. We'll just escape this for now because we have a time limitation. Let's go into the testing visual, which is the last and the fourth level. Um, so we have a plots and HTML widgets and other stuff that is visual to our user. So how we could test this kind of code? You can use the final, richest, and most fragile testing technique. Save a screenshot of affected component, then combine the screenshotting from Shiny test with the whole file snapshotting from the test data. It works similarly to snapshotting described in the section before, but instead of saving the text in .md file that we talked about, it creates a PNG file, which is like an image. Now, this is also means that there is no way to see the differences on the console, so we'll instead be prompt to run test that snapshot review, which uses a Shiny app to visualize the differences. So test that snapshot review will like compare the visuals between two images behind the scene. So the primary downside of this of testing using screenshots is that it's even the tiniest of changes requires a human confirm that it's okay. This is a problem because it's hard to get different computer to generate pixel reproducible screenshots. Differences in operating system, browser version, and even font versions can lead to screenshots that looks the same to the human, but are very slightly different. So this literally means that visual tests are best run by one person on their local computer, and it's generally not worthwhile to run them in continuous integration tool. It's possible to work around these issues, but it's considerable challenge. Yeah. Screenshot the individual element. The whole file snapshotting that is that are both very new feature, and it's still not clear to us what the ideal interface is. So for now, you will need to just to string the pieces together yourself using the code like we have a pass and an app, and we're taking a screenshot of the plot, and we're expecting this plot to be the same as we saved the pass in, which is plot init.png. And yeah, you're actually expecting or testing the result of this one and with this one. And yeah, this is the second argument of expect that file gives the file name that the image will be saved file snapshot directory. If these tests are in a file called test_app.r, then this two snapshot will be saved in tests, test that underscore snaps slash app slash plot and so on. Yeah, you want to keep the name of these files short, but yeah, evacuate. Yeah. Um, it was like testing visuals, but as it said here, it's hard to like to create a pixel perfect visual from the screenshots since um, we have a different version of um, browser, different version of even the library itself. You could have a different color or a different font or size, and this is for us is normal, but um, for the functionality itself, it's creating like it should be a very pixel perfect um, PNG, and it should be the same as what as the old one. So yeah, it could be useful for local testing, but in the production, I would see this as a good practice. And it will also like consume a lot of resources because we are saving as BNG files. Um, so yeah, this is okay. This is the philosophy. In the last thing, this document has focused mostly on the mechanics of testing, which are most important when you get started with testing, but you will soon get mechanics under your belt and your questions will become more structural and philosophical. I think it's useful to think about false positive and false negatives. It's possible to write tests that don't fail when they should and do fail there when they shouldn't. I think when when you're starting testing, your biggest struggle are with false positives. How do you make sure that your tests are actually catching a bad behavior? But I think you move past this fairly quickly. When you should write test, before you write test, the code, after you write the code, when you find a bug. So this is the three cases that you should write test in. And summary of this chapter has showed us how to organize an app into a package so that you can take advantage of powerful tools provided in test as package. If you have never made a package before, this can seem overwhelming, but you have seen package is just a simple set of conventions and structure and functions you can readily adapt for Shiny app. This is require a little up work from your side, but unlocks a big payoff. The ability to automate tests radically increase your ability to write complex app. And yeah, that's it for this chapter. And so we have four levels. I think it's the fourth. Uh, Testing JavaScript is good. We're using a simulator, and testing reactivity is worthwhile. And testing is the unit or a non-reactive function. So I think the first three is very important for us to handle or to try in our projects, since these are the main functionalities that we are using very often. And the visual itself is, I don't think this is could be in a production environment, but yeah, it's there for you if to try. I would say, and I will not use this if in a production. Um, So thanks everyone for joining, and in the next chapter we will discuss the security, and after it is the performance, and this is the final chapter. So we are very close to end this book club, and I hope everyone is uh, getting benefit from it. I'm getting benefit from it. I really learned a lot uh, along the way from you guys. So thanks everyone for joining, and see you next time.
Yeah, thank you, Ahmed.
Thanks, Rick.
Yeah. It's
See you.
always good to hear how you've also been adding or trying these skills out with the Python Shiny programming as well.
Yeah, it's very good because it's as I'm a first one of the first adapters so to Shiny for Python, so I was along the way from the beginning. So I'm trying to compare their testing. So they have actually developed their own way of testing. They called Playwright. They have this kind of framework that they use, and actually they build something like Rhino, but for Python. It's called like Type R, I think. And so yeah, they are advancing very much, very quickly in the last year toward we have a very good similar product as R, but in Python. So that's why uh, I see a lot of clients or organization are starting to adapt their technology to be in Python, since Python is more diverse and more full purpose language. So yeah, I think this is very